Okay, this is pre-calculus, notes on section 6.3, radian measure. All right, here we go. In the previous video, let me see if I can find it. All right, this is the ending of the previous video. So we took a look at the special case where the radius of a circle is equal to the arc length. And we found the measure of an angle given those conditions, okay? And here is approximately the degree measure. As I said in the previous video, it is not an exact answer because it is an irrational answer. All right, now let's go back to today's work. Okay, so now we've got a definition for that. All right, so it's a new unit of measure. Okay, a radian is a unit of measure for angles. And when we measure things, when we measure angles in radians, it makes some of the mathematics, in particular types of problem solving, a little easier. And it's a very natural, unit of measure for angles. It is not something that's used in the scientific community. It is something that's used extensively in the mathematics community. So we're going to be working a lot in radians as we come. If you need to convert to degrees, that's when you might, oops, what did I just do? That is when you might be interested to know that a radian is about 57.3 degrees. All right, moving on. Okay, make sure you get all of this in your notes. And here are some things that we're going to be thinking about as we start to think about radians. The easiest way to consider what radians are is to do so in what's called a unit circle. All right, so we need to know the definition of unit circle. Make sure you get this in your notes. It's a circle that is centered at the origin, and its radius is 1, okay? So here's the formula for circumference of a circle, all right? And so if you substitute r equals 1 into that expression, you get that the circumference of the unit circle is 2 pi. All right, so the arc length of the unit circle is going to be the same as the circumference. Okay, when it's measured in radians, there are 2 pi radians in a circle. Okay, so therefore, there are 2 pi radians in 180 degrees, and in half a circle, hold on, what did I just say? There are 2 pi radians in 360 degrees. That's a full circle. And in a half a circle, there are pi radians, or 180 degrees. Right, these are 2 things down here that you need to memorize. There are 2 pi radians in a circle and pi radians in half a circle. All right, so here's what I just said. 1 full revolution is 2 pi radians. Okay, now I'm going to do some calculations, and we're going to show you some of these other angles. So how about 3/4 of a revolution? Okay, first of all, let's look at what that angle looks like. Remember, in standard position, we've got the vertex of the angle on the origin, the initial ray on the positive x-axis, and then the angle is going to rotate counterclockwise. So 3/4 of a circle would end up down here on the negative y-axis. And that would be equal to 270 degrees. All right. Well, over here in blue, let's simplify what 3/4 of a circle would be. So if I wanted to know 3/4 of a circle, I'm going to take 3/4 of 2 pi. That's this calculation over here. And so if I make this 2 pi over 1, and if I cancel a 2 out of top and bottom, and then do top times top and bottom times bottom, I get 3 pi over 2. 3 pi over 2 is the number of radians in 3/4 of a circle. Let's move this over so I have enough room for the calculations. All right, so next, let's do half a circle. So again, the initial ray, we're rotating counterclockwise. There's the terminal ray. All right, we know that that's 180 degrees. And so if I multiply 1/2 times 2 pi, I get pi, all right? And actually, I said that on the previous page. Okay, right here, that there are pi radians in half a circle. All right, let's do 1/4 of a circle. Okay, so 1/4 of a circle, let's do this in green. Initial ray, terminal ray, okay, that's 90 degrees. So let's get the number of radians. I'm going to take 2 out of top and bottom. So top times top, bottom times bottom. I've got pi over 2. So there's pi over 2 radians in 90 degrees, and there are pi over 2 radians in 1/4 of a circle. All right, so here are some problems that look like what your homework, your next bookwork is going to look like. Here I'm being asked to find a degree. Oops, let me get my pen working. A degree and a radian measure. All right, to find a degree, I'm going to multiply 1/9 by the number of degrees in a circle, which is 360. Okay, so I just did that without even thinking and explaining it to you. To multiply fractions, you can simplify anything that's in the bottom that has a common factor with something up top. So a 9 could cancel out of top and bottom. A 9 goes into 360 40 times. So I've got top times top is 40. Bottom times bottom is 1. So that's 40 degrees. Now to do it in radians, I'm going to take 1/9 and I'm going to multiply the total number of radians in a circle, which is 2 pi. Okay. Here there are no common factors. So it's top times top and bottom times bottom. Now when we're discussing radians, we don't usually have just an integer. We have an irrational number. All right. In other words, pi is part of your answer. Don't try and simplify it further than that. That is the answer. That's the exact answer in simplest form. All right, so for 1/18 of a circle, right, to find the degrees, I'm multiplying by 360. 18 divides into 360. I know it does. Let me see. I'm going to use a calculator to figure that out. 20 times. Okay, so that's 20 degrees. To find the radians, I'm going to multiply by 2 pi, and I'm looking for a common factor. So 2 cancels out of top and bottom. So top times top gives me pi, bottom times bottom gives me 9. All right, try your bookwork.